Here's a look at a transformation of trig functions problem. I'm going to work on number 20. Let's look at 6 cosine of pi thirds x plus 8 pi fifths. The first question is the range. Okay, notice that scalar by 6 makes you go, instead of going from -1 to 1, which is the default for cosine, makes you go from -6 to 6. The amplitude is the max minus the min, so 6 minus -6 divided by 2, that's 12 divided by 2, that's 6. You know, it's the absolute value of this coefficient in front, usually. What's the period? You remember that the period is p equals 2 pi divided by b, where b is this piece out in front here. So this is really 2 pi divided by pi over 3. Well, if you need to divide by a fraction, probably the simplest way is to invert and multiply. Oops, that should be a pi. The pi's cancel, and you get a period of 6. So this is going to actually stretch it out. Now, in my mind, D is actually the trickiest part here, and maybe it's needlessly tricky. What it says is, by what fraction of the period of the function should the graph be shifted left to obtain the graph of f? So really, really, I think the more appropriate question to start with is, what's the phase shift? How far left is this? And the phase shift is really important. So how do we get the phase shift? Well, essentially, I need to factor out the pi thirds. So how am I going to factor out pi thirds? I'm going to figure out what I need to multiply this inside piece by so that I can multiply the whole thing by pi thirds. So that's actually 3 over pi, right? 3 over pi times 8 pi over 5. Now, if you distribute the pi thirds, you can see you get right back to here. Well, now you have pi over pi, right? And so really what we have here is we have 6 cosine of pi thirds x plus 3 times 8 is 24 fifths, right? This is a shift left by 24 fifths. 24 divided by 5, that's like 4.8. So what's the phase shift? It's left 4.8. And so the question they're really asking here is, hey, that 4.8, what fraction is that shift of the period? Which, I mean, once you have these two pieces, it's pretty easy to say, well, 4.8 divided by 6, that tells me the fraction. And that's kind of whatever you end up with there. You can simplify that yourself. I want to move on. Frankly, I would probably skip that. The phase shift is really important for the sketching. Okay, so let's sort of think about the sketching now. If you have the phase shift, you have the range. Think about this. Your max and your min is going to be -6 min, 6 max, right? A shift left of 4.8 says I'm going to actually start this gig at -4.8. I'm going to end this gig 6 to the right of that. Let's see, add 4.8, add another 1.2. And that's what the cosine curve is supposed to do. So cosine starts at the top, goes down, goes back up. Oop, hits that dot. We could add another 6. So what would that be? 7.2. And it's supposed to repeat every and that's a little bit of an ugly graph. But let me show you sort of, Desmos can do, of course, a beautiful graph, but key in on that shift of left 4.8. Okay, so you can see there's my equation. You can see the -4.8, the 1.2. Look at the max at 6, the min at -6. And then the last part says, okay, you can keep that going right and left as much as you want by adding another 6 and subtracting another 6. What would happen if you shifted that up by 7? That's the very last piece. And hopefully you can see shifting it up by 7 moves this dot up 7, right? Just add 7 to the y value. It moves this dot up 7. So now, essentially, instead of the range being -6 to 6, the range is +1 to +13. Hope that helps.